What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another regular live stream where we try to build something from scratch. Usually something sort of interesting, but it really just depends on how much progress we can make on any given stream. But last stream was pretty cool. We actually did manage to get the new Mesche programming language that I've been putting together working inside of Flux Compose, which I feel like this is like the third time we basically try to do the same thing over again, and today is going to be more of an extension of that. Mainly because we're going to try to continue building out the abilities of the language to describe things we want to render in Flux Compose. So we're going to try to write the Flux Harmonic thumbnail, which we basically did last episode, write the full description for that thumbnail in Mesche. So currently it's being written in C code, but we're going to try to replace that C code with Mesche. And it's going to require us to do a few different things, and we'll talk about that in a little bit. Hey, Gun, nice to see you. All right. So some updates. Here's some things that have happened since last time. First of all, I was able to get a mark and sweep garbage collector implementation working. I mean, it's probably not the most efficient or effective garbage collector, but it does actually work. Yeah, it's another thing that I was reading from the Crafting Interpreters book that I mentioned last time. And the implementation is not very hard. I mean, basically all you're doing is taking a look at all the roots, the objects that the VM and the compiler have access to, immediate access to, and then based on what they have, you sort of walk the tree of references to other possible objects that might be live as well, and mark all of those as being in use, and then you go through a final pass of all the objects that have been allocated, and any of them that are not marked as in use, you just delete them or you free them. So that's currently working. Pretty happy that's in. Had a little bit of issues with one or two aspects of it, but I realized it was just something stupid I was doing in the code, as always. So that's cool. Now we're basically moving on to bigger and better language features. So earlier today, I spent some time adding standard scheme style function definitions, which if you are not familiar with scheme, let's go into the code really quick. I'll show you exactly what I'm talking about. So let's see, is this where it was? Or was it here? No, it's not there. I thought I had changed one of these samples. Anyway, so there's two ways you can define a function in Scheme. One is to do this sort of what I'm doing in the selected code snippet here at the top, which is you just define a variable called whatever you want and then assign a lambda to it, an anonymous function to it. And because Scheme is a Lisp1, or it has a single namespace for both function and variable symbols, you can define a function into a variable and then just call the variable and it will call that function. So the real way that you define functions in Scheme is more like this, where you wrap the symbol and the argument list inside of parentheses. Let me just do this really quickly. And then you end up with something that looks like, I need to insert a parenthesis there. I think let's take that one off. All right, so that's what Scheme normally looks like whenever you're defining functions. And this is really just syntactic sugar. It's doing the same thing under the hood. It's defining a lambda and assigning it to a variable. So that was pretty easy to add. It's just a matter of changing sort of how the syntax gets parsed. Hey, Jackson, nice to see you. And then the other thing that I spent some time adding was, where's my notes? Initial support for keyword arguments. So you've probably seen languages before where you can have certain positional parameters where you pass in specific bits of information. And then you may have specific keywords you could use for additional parameters that are optional. So I've implemented something like that. And if we go take a look at the code for that, or the example for that, rather. Look at keyword args here. We can see I'm defining a function called, really need to set scheme mode on a binding for this file type. A function called keyword test, where I have a positional parameter called str, and then two keyword parameters, one x and one y. And based on what I pass into those, it changes the values that are in the function. So it's basically just like creating another couple of local variables that can be not really dynamically bound, but the value can be provided. It may or may not be provided whenever you call it, so it's kind of nice. Let me see if I can compile this really quickly to show you as an example. let's do this, compile, and then and flux build / flux compose lib mesh samples, was it keyword args.msc. Let's see, it might take a moment to build because I updated my system today. Gun says, I'm also reading the CI book and fought with the Mekonda mode in Java 17. Finally, Java 11 worked. Interesting. I haven't really messed with Java programming in Emacs. Meganada mode. Okay, never heard of that one before. Okay, I didn't expect that I was going to have to install some packages, but I pulled my Geeks repositories today and refreshed everything in my system, so apparently we've got a little bit of that to deal with. Let's see how long that takes. In the meantime, let's talk about what we're going to be doing today. So Mesh needs the ability to describe a scene to be rendered for Flux Compose. So really this is the thing where Flux Compose is going to provide APIs for it, but it's going to be done in Mesh, obviously. So something like this, where you define the name of a scene and you call the scene function to actually do the definition of the scene. You give it a width and a height for what sort of the renderable area should be. And then the members of the scene, which is a list of members of the scene, I guess, is something that should be drawn into the scene. So whenever you write this code, you should be able to take that and then render it to an image at the end. So today we're going to try to put together some of these functions in Mesh and in C to create the necessary objects to sort of wire back up to the things we had written a few weeks ago that did some of this work. But now we're going to wire it up through Mesh and actually end up with a better way to manage it, I think, because now we have garbage collection, we have a lot of other things that are nice to have. And we're basically going to try to see if we can write enough code to replace the hard-coded C code that is generating the thumbnails that you see now. Today we are also using a thumbnail that's generated by Flux Compose. So we're gradually, building up the basis of the platform. I know we keep like redoing certain things, but I think we're going to get to a stable baseline now because I'm pretty happy with where Mesh is headed. I mean, I'm making pretty fast progress with it, and it's at a point now where it's becoming useful for this project. So I think this sort of rewriting of the same stuff over and over is going to stop now. I think we've had the nice basis for at least the graphical side of things, and we'll be able to continue building forward on that in the future streams. Let me jump back over and see if that got installed finally. Okay, cool. So the code actually did work. If I go back to the keyword args example, I'm calling this keyword test function twice. First is with the string hello, and then only the x value set to 3. I don't have the ability to write new lines yet. That's something we need to add. But you can see here that the strings that we're formatting using the display function up here is x is 3 and y is nil. So since we didn't specify a value for the y keyword parameter, it defaults to nil. Setting the default values for keyword parameters is something I'm going to work on. It's a little bit trickier than I thought, so it's going to need a little bit more time. But maybe it's something we can do on a stream sometime if I don't do it before then over the weekend. So we got that call, and we have the second call that has hello again as a string, and then x is 5 and y is 15. So we can see that y also can be overwritten there. So that was pretty fun to put that together. It just goes to show that the model that I have right now is pretty flexible, and it enables me to do things like this so that Mesh functions don't need to go and look at all the keywords and try to decipher them. We can basically make it part of the normal calling conventions of the language. So pretty happy with that. Jackson says, I'm working with Java in school. Should I try Meganada or just stick with LSP? And Gunn says, I'm using Doom where Meganada comes out of the box and LSP needs significant tinkering. Okay, that's interesting. So I guess it's like an alternative to LSP. I've heard the LSP mode in Java, while it can be pretty advanced, it also can be a pain to set up. So definitely good to see there's other options out there. All right, so for today's tasks, we're going to start building up a set of mesh functions to replicate what we want in the scene description. We're basically just going to write the shell of these functions, and then we will go try to wire them up to C functions internally for building the actual scene objects, and then start rendering that scene data again. So we're going to get rid of all the hacky stuff that we had in there previously that's hard-coded in C code, and try to replace it all with actual C API functions that are called from Mesh. Then we may have to, I think we'll do it pretty fast. We'll end up adding an object type in Mesh for handling C pointers. So since we're going to be dealing with C a lot, or C data types, I guess. When I say data types, I mean more like structs and even arrays. We need a way to handle pointers to those, and also potentially take over the duties of garbage collecting them or freeing them whenever they're not being used anymore. So I'm going to add an object type for that to Mesh so that you can handle a pointer to some arbitrary C allocated memory in C. Then we probably will also need a basic list object type. We're not going to go so far as to do like const-based lists right now. We're going to do something simpler where we just have a dynamic array. But we will probably end up doing const list at some point. But for today, we just need to have some way to express a list for things like having this members list, where you see that we have a members keyword, and then there's a list object that gets passed in with multiple members that are a part of that. So we're just going to try to make that work. So that's pretty much it. We're going to jump right into it. So the first thing is to build a set of mesh functions to replicate what we want in the scene description. So I think how we can proceed with that is to pull up the original, one of the original examples here, this basic graphics.fxs from the previous iteration of the scripting language, as we've had so many of these by now. I'll go drop this into thumbnail.msc. So this is what we ended up producing by the end of the previous stream, where you basically have, we can call the show preview window function to make the preview window show up. And then we call the Flux Harmonic thumbnail function, which is basically the hard-coded C code for rendering the thumbnail. And then we call render to file to render that that scene to a file effectively. So we're going to change around some of this stuff right now, but we're going to start with trying to paste in some of what we were doing before and adapting it effectively to the model we want. So we don't really need this circle stuff. We're not going to be drawing any circles here. What we will need to do is define Jost font. And maybe we can have like a, what should I say, load font. I think I had some kind of example code for this at some point, but I don't remember what it was. Family is Jost. Size is, well, let's see, what size was I using in the C code? Let's go back to graphics.c, Jost. I think it was 100. Okay, that sounds smaller than I expected, but we'll try that and see what happens. Is that the right one? No, I don't think it's right. We're gonna go to thumbnail. 450. That sounds more like it. Okay, so 450. We want Jost. Also, there is a sort of designator here for semi-bold, which is kind of interesting because we need a way to put those words together, and we don't have a way to do string concatenation in Mesh yet, but we could probably add that. So we could say weight semi-bold. We could probably do it that way. And that would allow us to define a font and or a font variable that's holding the result of loading a font. Maybe instead of calling it load font, I would say font load, because we usually want to have the noun first and then the verb in these sort of scheme style API designs. Okay. So then we'd also want to have the images that we need to load. So define bg image, image load, and then we would give it a path to the image. And from this, I think I was giving full paths. That does make sense. So let me just grab this full path here and put it in right there. Whoops. Oh, what's going on? I think Lispy is doing some trickery. If you haven't heard of Lispy, it's basically the it's one of the ways that you can have structural editing of Lisp languages inside of Emacs. And sometimes it's great, sometimes it also drives me insane. Okay, so now we got that set there. We also want the logo image. So image load. Maybe we can clean this up a little bit too to make it look a little bit prettier. Whoops. I can close that. Probably eating up my CPU. So go back to the previous file and grab the logo path. Now, I may need to set that this is PNG, or maybe just the file type can be good enough to indicate that. Can you just let me delete the quotation mark without having to give me trouble. I know there's probably better ways to do this, but here we are. All right. Who knows what Lispy did this time? All right, so we inserted that. Cool. All right, so now we have our images loaded, or in theory, this is the code that would cause that to happen. We also have a font loaded. Let's just put that back where it was. And then we want to describe a scene. So let's say like Flux thumbnail. And then width and height. I'm going to go with the same width and height as what we're doing with the preview window. So in fact, I can just define width. And define height. And this is probably the most elaborate code I've written in Mesh so far. So we're going to see how well it works. Width, height, and then I hope this works. Width, height, and we'll leave this members off for now, I think. Just to, let me go right here and delete this whole list. Boom. Let's just see what happens when we do this. Is that right? No. Okay. Okay, so we're going to take this out. And then render graphic, that doesn't exist. This doesn't exist, but it does exist, but it doesn't take a scene as a thing to be rendered. So maybe we'll go back to that in a second. So for now, we have enough to say that we're loading fonts and images, and we're creating a scene, saving it to a variable, and then calling render to file. So this could be enough to at least get it started. So what I want to do now is just see if any of this stuff is going to just blow up in my face. First, we're going to need to do some function definitions. Font load. We only have keyword arguments here, so I'm going to say keys, family, weight, size, display loading a font. Probably should add a new line function as well. I really need like a format function, but I just haven't gotten there yet. But maybe if we have time today, I can start on that a little bit. Also, define image load, and then that's just going to be a path because we don't really need any other parameters there. But I don't know. Sometimes it feels like you do need to be more explicit with the keyword arguments in this type of document, just so that everything's clear, and also gives you possibilities for adding other things later. So we'll think about that one for a minute. Display loading and image. Okay, so that's those two functions, and then we also need define scene, and we have width and height right now. So keys, width, height, display defining a scene. So I'm gonna have my fingers crossed here to hope that this doesn't completely crash and burn. We can run that in the compiler. So I'm going to use examples thumbnail.msc. Yeah, so this is invalid next size. I don't think that has anything to do with mesh. Could though. Invalid next size. Interesting. Okay. So let's run that in GDB because I have no idea when that's happening. Run. It's a libc error. Interesting. Okay, so we may have to start commenting some stuff out to figure out where this is coming from. So obviously we're calling realloc, and it is not happy. Let's see, old size, new size. Never seen this happen before. It's kind of weird. Let's see. Make constant, chunk constant, add, array right. Okay, so we're gonna just bounce out of this for a second. And let's comment out a lot of the stuff just to try to see where the problem is coming from. We'll comment that out too, and we'll get rid of that. And we'll get rid of that too. So just defining width and height. Let's see if that works. All right, so that seems to be fine. No problem. Let's do our font loading function just to make sure nothing there is wrong. Okay, so something about this is wrong, which is very strange to me. Define font load keys, family, weight, size. Let's take the keyword parameters off first and see if that has anything to do with it. Nope. Very interesting. Let's try this instead. We'll say font load lambda. Okay, let's try that and see. So something in general is just wrong here. Let me go back to where we were before. Okay, so diagnosis time. If I work backwards, once again, we have the floppy backdrop. So let's work backwards using GDB. We'll go and run the thumbnail example again with this very simple example. I'm gonna run it. I'm gonna check the backtrace, and we're gonna go back a little bit further. All right, so compiler C, compiler make constant. All right, so that's about as far back as we need to be. Parse string emit constant. So something about this one, I think, is the problem. Unless it's one of these other symbol names. Let's see what else we got. Compiler C, parse lambda inner. So it's definitely inside the lambda parser. Parse block, parse expression, parse list. So I think we're getting down to the function call of display. Parse expression again, parse string, emit constant, make constant, constant add, value array right. Okay, so something weird is going on, and I think it even has to do with just the display here. I don't see it trying to do any garbage collection yet. And let's see, mem is that, mem pointer is 0, which makes sense because maybe it hasn't been allocated yet. Old size 0, new size 128. Interesting. Okay. Let's go into the compiler and see what we can find out. So this is coming from chunk constant add array. Ugh. Value array. So I think we're also back in compiler at lambda inner. And if I were to go look at the good shell again and check my call stack, parse string, parse expression. This is inside of, well, I can't really tell, excuse me, can't really tell where we're at. You know what? Let's just start doing some good old print debugging here. Go back to the compilation buffer so we can see what we're doing. Keyword. All right, so the first thing we need to look at is probably right, not in keyword. This is for arguments. So we're definitely inside the argument list. All right, so printf found keys. Let's just get there first and see it. Whoops, what just happened? Oh, code formatter. Okay, so found keys, got that. What else? We're in the keyword list here. If we're doing it in advance, we're doing parse symbol. So we can say printf before parse symbol. And then say after parse symbol. I should really be stepping through with the debugger on this, but you know, don't have all that set up right now. Okay, so 1, 2, 3, we've parsed 3 symbols. I wonder if I did something, like maybe I checked in a bug right before I finished writing this code, or before I checked it in. Why is it doing this? Because that looks horrible. Huh. It wants that leading or the following comma. Let me see if I did something really dumb here. So we parse the symbol, we consume the right paren. which we didn't need to do yet. Function keyword add. Let me double check this. So printf before add keyword arg. Super nice to have to deal with this right now. Huh, okay, so all those came through okay. So what about, where are we? Parse inner, parse block. Oh, parse block. Okay, so I'm barking up the wrong tree entirely. So parse block is where we parse the function body. Parse block. Parse block. Parse block, there we go. For some reason, eglot's not cooperating, which is kind of weird. All right, parse block. And from there goes a parse expression, which I think happens... Where was it? Right there. Okay, so we're parsing the first expression, which is at display, I think. Parsing expression, parsing list. And then we try to parse the first item in the list. So definitely it doesn't have anything to do with keywords. Let's go delete these 2 lines because we don't need that. And this is going to be in underscore list. The place where I think this is happening. Okay, so we do have some keyword args business here. So maybe there's something I added here that also is a problem. So operator call, we're not seeing that one. Hey, Garjola, nice to see you. You're at work? Yeah. Sometimes you gotta be at work. Okay, so let me double check what it is that I'm doing wrong. So parse list, parse expression, parse. All right, so we have the keyword and we have the expression. Oh, no, it can't be. Because we're not calling anything that needs keyword args yet, are we? No. We're only calling a normal function. So it should be right here. So printf parse argument. And then after parse argument. Just curious, like where this is going on. Go to the compilation buffer, run it again. Huh? There's just no way. There's just no way. Yeah, well, you're seeing the interesting vagaries of of writing your own language compiler, because for some reason using printf statements here apparently causes whatever the problem was to go away. Wow. That is perplexing. There's something going on, I think, with some part of the code. Did I actually invoke that function yet? I don't think I invoked it, did I? I haven't set anything up aside from just running this script. So I'm trying to figure out why we would have a malloc issue until I use a print line or printf here. That just doesn't make sense to me. It doesn't compute. Valid next size? How does that have anything to do with anything I did? Maybe it means that I'm passing a reference to something in memory and it's getting caught. Okay, so how about this? Invalid next size. Let's go look at mem.c. Mem. So the next size should be, where is it? I'm calling realloc. So maybe it doesn't like what I had given it. Let me go back to the good shell. It has the parameters here. Old size, new size is 128. I don't see what the problem is. Unless... And the memory pointer seems to be fine. because it would be null if it hasn't been allocated yet. That's generally what you do with realloc. If you pass a null pointer and ask it for a number of bytes, it's going to return you a new pointer that you can use. So if there was a problem, it would have bailed out right there, I think. Except for the fact that it crashed. Okay, well, I'll use some tools to diagnose that another time. Because printf seems to solve the problem, we're just going to continue with that for now, which is just horrifying, but it is what it is. With live streaming, you can't get stuck on every little problem. Okay, let's get back to the code and see if everything else will start compiling as well. Let's just delete that. All right, so we've got a few little functions we're defining. Those all seem to be good now. Show preview window. That should cause a preview window to show up. Boom. All right, so the old code is rendering just fine. And I'll go ahead and throw some more of these things in. All right, so unaligned T-cache chunk detected. There's a lot of really dumb issues. I saw your message, Garjola, about give me encouragement about that. Hey, Bill, nice to see you. You're not late. Yeah, there's definitely some problems here. Ashraz has very nicely given me some tools to fix that. I just haven't merged it yet because I need to get some other things moved out of the way first. Okay, so let me see. We've got all that stuff here. Did it print anything out to the screen? Yeah, loading a font, loading an image, loading an image. Okay, so it did print those things out. Cool. Now we're going to define the Flux thumbnail scene. What is scene going to return? Nothing. Let's just return T for now. I'm kind of curious what it has in it. Let's check that out. It ought to have nil, but I'm not certain because I didn't really think about that case. Let's display scene is, and then display Flux thumbnail. Let's just see what that prints out. Okay, close that. All right, scene is blank, so who knows what it is. Hey, Gavin. All right, so let's just delete that. That's not really helpful right now. I'll return a T from here for now, just so that there's something being returned. Oops, I just wanted to catch the output. Yeah, scene is T, so returning that did work. Okay, so we got our basic set of functions set up here, and what we're gonna need is some C-side functions that will allow us to actually invoke this behavior. So what we can do, let's start with font loading, and maybe font load internal. We need a way to have like some internal functions. Garzola said, I also started reading crafting interpreters. I'm doing the Java part. I was too lazy to set up a Java dev environment. Yeah, well, it is kind of a pain in Emacs, that's for sure. But I'm happy to see that a few of you are doing crafting interpreters. I'm telling you, that book is awesome. Really good. It has unblocked me from my, you know, it has enabled my dreams of being a compiler author, basically. Okay, so we're just going to pass on the family weight and size here, which obviously I could just pass this directly to a function, but if I want keyword args, I'm not going to support keyword args for native function calls, obviously, because the native functions won't be able to read it. I mean, it's possible that I could pass them in somehow, but for now, they won't support it. So let's write a font load internal function in C. Graphics.c, we can have this down here somewhere. Actually, maybe what I'll do is go into, what is it, texture.c? Texture.c. No, font. Font.c. Here, let's make the function here. So func load font internal. Okay. And we want to have 3 parameters of this function. Requires 3 parameters. Don't really need validation so much. I mean, it's always possible someone could call these directly, but It would be ideal if they didn't. Now, once we have module support in place, we could export only the mesh functions for this and not the internal functions. So that would be one way to obscure that from the user, which would be nice. Okay, so we're gonna grab all the stuff we need. And what do I have for loading images? Flux font load file. What do I have for loading based on font name? Let me go back to the graphics.c. Yeah, Garjola heard my daughter screaming. I don't know. She's playing, actually. Sometimes it sounds like she's screaming, but she's playing. She just gets a little bit upset when people don't play the way she wants them to. If you've ever had a kid, which I know Garjola has kids, you definitely are familiar with that. Okay, so texture. Hey, Brian. Yes, it is a beautiful data write a scheme implementation. I wouldn't call it fully scheme because I'm kind of, going my own path, but that's sort of the point. Okay, so font load, font file. So we need to resolve the path first. I basically need to copy this code over for the most part. I'm going to put that into font.c, drop it right there. So what we're going to need to do is generate a string for the font family and the width. So what we can do here is just have a string buffer effectively. Char font spec. We'll put, I don't know, 100 characters there. That should be sufficient, but we may have to readjust that at some point in the future. Then, let's see. We're going to need the pointer to the C string for the first two parameters, I think. Yeah. So let's grab those first. We know we have 3 parameters at this point. So for args, the first parameter, we're going to say as C string, and we're kind of assuming that that's a string. I guess we should probably do some checks on that. I might need to add some helper methods for validating this stuff. So char star name, or let's say family, char star weight equals args 1. This is probably going to blow up my face immediately, but we're going to figure it out. And then double, which we're going to cast down to an integer, since double is the only number type we have at the moment. Size equals as number, args 3. Okay. And now that we have those, we can pass in, let's see, where is it, the size? I think it wants an int. Size, right there. Let's double check the signature on that one. It was telling me, I think. Control H dot. Nope, that didn't help. Okay, so uint8t. Great. That's definitely not big enough. How did that ever work? Seems like the wrong type to use for this. Size. Font size. No. Need to change that. That seems wrong. Let's see. Set pixel sizes. Great, we don't have access to the LSP information for that one. It's not working for some reason. Oh, there it is. uint. So it's just a uint. Probably not a uint8. I mean, you don't really need a full uint for font sizes. We're gonna have to go back into flux.h and change that signature, font size. Change that to an int now. All right, now, what else? We have the font path, etc. So I'll need to build this font spec. So the first thing I can do is use memcopy on the family, copy it over to the font spec. It really needs to be zeroed out. Yeah, I could probably do memset or something. Memset, font spec. What are the rest of the parameters to memset? Oh, it showed me. It just took its time. Okay, so the pointer, the number, and the size of care. Okay. I think that's going to be sufficient. All right, so font spec. Wait, hold on. I think it needs to be the value. Come on now. Eglot, help me out. Okay, C. Set in bytes of S to C. So I want to set this all to zeros. I suppose I could just put 0 there, right? Maybe not. And then I think the last one is actually the number of characters set. Can you give me the set in bytes? All right, cool. So 100, fine. Obviously, my C skills are lacking. Mem copy family font spec. We're going to copy to the first part of the string. We're going to start at 0. Come on now. Give me the details. Mem copy. I know I call it somewhere else. Mem copy. Okay, so yep. So we need to have a number of characters. New value. Okay, so font spec, size of care times string length, family. And then what we can do is font spec plus strlen family, which I should probably cache that. Let's see, size T, I guess. No. What's strlen return? It's not what I'm asking. Come on now. Can I go definition on that? Jeez, this is really not helping me. What is happening? Info. Can I find this information in info? Let's see, info apropos. It's gonna take forever, isn't it? Strlen. Let's see what happens. Garjola says, by the way, eglot plus clang D plus clang format works great in less than 10 lines of config with use package. I'm using CCLS, but I may need to try clang D because I'm having issues. Okay, there's libc. Oh, God. Info back. Info forward. History forward. There we go. Thank you. Hey, Porf. Okay, so size T. Thank you. Finally, I get answers to my questions. We're going back to, what was it, font.c? Okay, strlen. So what I want to do is say size T family len equals strlen family. So then here I will say family len plus 1. Yeah, good call, actually. Gun. I need to put the, well, actually, I've cleared all of them to /0, so it should be fine. Well, so long as the memset works. Okay, so I'm setting this to the location 1 after, which should give us a space, but actually doesn't give us a space because they probably all need to be spaces, right? Okay, so then, here's what we're gonna do. Font spec. This is terrible. I really need another way to do this. Let's look at sprintf. There is an sprintf, isn't there? Let's see. Info search sprintf. Okay. I should probably be using that kind of thing instead, right? Is that put to a string? Sprintf. Okay, cool. Output is stored in the character array S. Fine. Let's do that instead because this is just idiotic. Going back to font. Why is it not showing it to me? String dupe. String dupe won't let me do multiple strings together, will it? Let me check that one too, just in case. So search for string dupe. Const care S. I don't need that one right now. Font. Okay, so the problem is we have to make an assumption. All right, let's just do this the easy enough way. How about this? Let's do it this way. So sprintf font spec %s, and then we're gonna say family and weight. It's probably a better way to describe that. And we'll just comment the rest of that stuff out for now. Okay, let's do that too. And we'll just leave that right here for now. So that should give us this font name. So if I put font spec here instead, then it should be able to find the font path. I wonder if I should throw an error in Mesche. C++'s auto is great. Yeah, that is, you know, something I could consider in the future, but for now we're just going to go straight C. Okay, so we need a font variable to hold on to it. And we're gonna have to return a value, which is probably the place where we're gonna have our pointer object we need to create. So flux font, I believe it is, star font equals null. Then font equals font path is null. Okay, we're back to there. Great. Then we can return the font, but we're gonna have to wrap that. So this file is also gonna have to pull in mesh, it seems, which is fine. Object.h. So now we need to add a new type for object kind pointer. This is gonna hold a C pointer, basically. Go drop it down here somewhere. We'll just copy this one. And we're gonna do the thing that you shouldn't do and have a void pointer. So ptr, and we're gonna call this, we're gonna type def it here. So type def struct object pointer. Garzola says, are you afraid of name mangling now that you write your own compiler? It's not an issue anymore. I'm not really afraid of name mangling because you can use extern C, but still, I mean, C++ has its own complications, I think. It has a lot of things it brings to the table as well, obviously, but I think I'd rather avoid it for now. So let's see here. We have our pointer now. I probably need to have a function to make one. So I'll drop one right there. Object pointer make pointer, and then I'll just pass in the void star pointer. Then we need to go into our implementation file and then do the same thing. Let's go right here. ASPrintf is another alternative. Interesting, I haven't heard of that one. All right, so object pointer equals alloc object VM object pointer object kind pointer, and then pointer ptr equals ptr. Also, I think I should have an is managed. So bool is managed, which basically means who's managing this. Is it managed by Mesche, or is it by the host process? Because we want to make sure we don't try to free it using the garbage collector if it's managed. Or let's say this, we need to get our terminology straight. It is managed means that Mesche is managing it. So if it's managed, then Mesche will try to free the pointer. All right, so return pointer. But we also need to say pointer is managed equals is managed. And we're gonna go back into object H now and add that in. So bool is managed. That's probably fine there too. Okay, so now we also need to add a couple more helper things around, like for instance, pointer p as pointer value ptr, and this needs to be changed to pointer. So this will give us a little bit of a readout whenever we print one of these using the display function. And also I need to know how to free it as well. So in this case, we can say object kind pointer. We will create a new scope here, object pointer, pointer equals object pointer, object. All right, so if pointer is managed, then we also need to free that. Now the free macro is not for random memory locations, so we're going to use actual free here, I believe. So pointer ptr. Let's just add a little log statement there, freeing a native pointer. Just to see that happen, if it ever does happen. We probably won't end up hitting a GC because I've got the baseline threshold pretty high for, you know, such a small script, but we'll see what happens. Also, we need to free the actual object pointer object. All right, so that will allow us to free that object once it needs to be garbage collected. Why are you upset? Redefinition of pointer? I don't think so. Okay. What else? We've got that done. The printing is also written, which is good. So now we just need the macro for getting to the pointer object. So we can do this. Pointer, just do a little copy paste of our own code here. Pointer. Now on both of these, we're just going to drop in pointer, pointer. And then if we go back to font, we can say mesh object create pointer. Oh, but the problem is we need the VM, which begs the question, should I be passing in the VM object to all these functions? I think the answer is yes, because if we ever have to allocate anything, we need a handle to that. So we're gonna have to change how that works, which is no problem. Why use printf when puts will do? Just force of habit. I mean, a lot of times I'm formatting things, so puts doesn't allow you to format strings. All right, so create pointer, and then we're gonna say true here because we want Mesh to manage that object going forward because we're sort of passing it through as part of the API. So let's see what happens. I need to include mesh.h, include mesh.h. You good? Okay. I think I have that in object.h. So that's effectively exported, make pointer. Okay, that's there. And the other thing was I need to change the way that native functions are called. So I need to go into VM. And let's see, native function. Right, okay, here it is. So I'm gonna say VM here, that we're basically calling into the function pointer, but I need to go change this function pointer pointer type to take a VM in. And it seems I don't have access to VM right here. But I do have access to mesh memory, which is good enough. Because it's basically the same thing as the VM. I'm just sort of abstracting it a little bit. I may have to change that. So with the addition of the GC, I had to come up with a way to sort of abstract what the memory manager is, which technically speaking, the VM itself is the memory manager, but due to sort of like a desire to not have circular references between modules, you know, VM needs access to a lot of modules, and those modules may need access to VM as well because they want to allocate memory, but you don't want to have like circular references in your code. So I sort of abstracted the concept of the memory manager into its own module and sort of pretend that it's separate when it's not really separate. So let me go back then to vm.c. We're going to cast this now to mesh memory. And then the font.c. That's going to be a little bit tricky. I don't really like that, but that's the way it's going to be for now. Because we're going to have to be doing this sort of casting dance, which is not great. Mesh, memory, mem, okay. Whatever, we'll just live with it for now. Mesh, memory, star, okay. And I think we fixed the pointer, right? Where is that defined? Come on now. I don't even know where that's. Function pointer. eglot is not cooperating, or maybe it's CCLS that's giving me trouble. Okay, object.h, of course. No. Function pointer. Where is it? vm.h. Perfect. Okay. So hold on a second. I'm in vm.h. So maybe it is fine. I don't want to spend too much time on this. Let's just make it work. So we've got a couple of instances of that function that need to be updated now, I think. So let's see if we can find them through the errors. Interesting that we're getting some complaints in places I wasn't expecting. Let's see, font C. All right, so mesh object create pointer. What don't you like? VM is undeclared. So font C 261. Because it just takes mem in. All right. Okay, let's do that. It's the other way around. I actually want VM here whenever this is mem. Implicit declaration of function. Well, it's declared. I don't understand what the problem is. Incompatible types when returning type int, but value was expected. Create pointer should be returning a value though. Oh, no, it doesn't. Okay. So this needs to be object val to wrap it in a value. And that should make that part happy at least. Implicit declaration of function. So it doesn't know. Doesn't know that that function exists, which is a little bit weird because all that stuff is part of the public interface of the mesh library. Let's check it out real quick. So include mesh. We're including object.h, and that function is part of object.h. So I don't understand what the problem is. Object.h. Mesh object make pointer. Did I call it the wrong thing in the code? Create pointer. Got to get my terminology straight. Okay, create pointer. Let's call it make pointer. There we go. That's going to be better. Something else is a problem now. Too many arguments. Okay. What was I doing wrong? Object.h. Okay. I need to update this. Bool is managed. Okay. Segmentation fault. Function requires 2 number parameters. Which one would that be? Which function even says that? Function requires 2. Show preview window. Function requires 2 number parameters. That doesn't make any sense. Go back to thumbnail.msc. Interesting. I wonder what's going on there. Unless we're getting some garbage collection going on. let's take a look at that real quick. Got some stuff happening. Let's go to mem.h. And we'll log to GCs for a second to see what we see, if there's anything happening. Just a bunch of allocations. I don't see any GCs yet. Okay, so it's not a GC problem. Something else is going on. Function requires 2 number parameters. It doesn't make any sense. Where is it? Show window D. What happened? Sometimes I think show window, preview window. Show preview window, width and height. Should have those values. Let's try this. Display a width. Oh, come on. Display height. Yeah, the values are totally fine. I don't understand why it's oh. Hold on a second. Interesting. It never got me to update those functions. Huh. This is why it's happening. Mesh. No. So we don't need this for anything else. This is going to work now, I think. We need to go update the signatures for those as well. Is it flux.h? Funk. There we go. So you just need to add mesh memory as a parameter of those. So then in graphics, we have that one, funk. We have this one. We'll update that one. I'm surprised I didn't get compiler problems with that. Maybe it's a warning. I just didn't see it, which is a common problem I have. I just don't see the warnings that are being written out half the time. All right, here we are. So it seems undefined variable loading a font. Interesting. Let me go back to the thumbnail file. I'm going to take, see, loading a font load internal. So we're calling font load internal. I don't know. Am I getting an actual indication that it is doing something? Let's go back into font.c. And then when we finally have the font spec, we're going to say printf loading font spec. Font spec. Okay. Excuse me. I guess I could have looked at the resolve font path. Loading font spec. I don't see that. Oh, that's why I haven't registered that function. Why is it not giving me an error if it doesn't resolve the function? I got to add that, obviously. Okay, so let's go back to font.c. We're going to take the signature of this function. We're going to add it to flux.h in the fonts section. And then we can go and wire this up in the main.c file. Main, whoops. Come on now. Main.c. So where we wire the other ones up, we're going to do the same thing here. I really need to make a function inside of Mesh that's taking care of this. VM define native and VM. The name would be font load internal, and then the pointer would be the function right here that we just created. Now in theory it should, oh, now invalid next size again. Randomly we just get more errors. I just don't understand what's happening with that. Let's just try this for a second. Who knows, man? This is very inconsistent and frustrating, to be honest. So if I take this out, there's some really freaky things going on here. Strange things are afoot at the Circle K. Okay, so let's see if the font did load. Loading. Excuse me. All right, I'm going to go back into the existing hard-coded C code. Just font. I'm going to stop loading it so we don't keep seeing it. Okay, so I don't want to see anything about fonts. Loading a font. Undefined variable loading a font. There's something strange going on with the language, I think. Undefined variable loading a font. Let's take that out to see if this helps at all. Parse argument. Whew. Nothing but trouble. All right, let's see. All right, so font load internal, excuse me, has been registered. Of course, this shouldn't be a problem, as I always say before we end up with problems. GDB. Okay, value print. Oh, where am I doing that? The disassembly. Constants, values, constant. How would that be a problem? So that's after the compiler finishes. Parse define, parse lambda. Oh, okay. So this is the lambda itself inside the function here. It's trying to disassemble the function, and somehow it throws up on the constant value. That just doesn't make sense. Let's do this really quick. That must be why that happened. Undefined variable, loading a font. Somehow, this font load internal is not showing up. Did that happen after I registered the function name? Or has this always been happening? This is so bizarre. I don't understand what's happening anymore. Okay, so I'm going to go back and take a couple things out of the script. Like, not that. I'll take these two display commands out. We don't need that anymore. And then take a look at the output. Okay, so still undefined variable loading a font. Let me take a look at the disassembly and see why it's doing this. Loading. So it's even compiling it that way, which makes no sense. Well, I guess it does make sense because that's the constant that's been loaded before. Let's see. Yeah, there's a really strange bug right there. Because it should have font load internal. Why is it not actually picking that up? Okay, so constant loading a font, display. Okay, that all makes sense. We'll pop that back off. That's what we want. then read global. Read global should be pulling in this font load internal. So let's check on compiler.c and read global, parse identifier. So parse identifier. And that's probably happening inside of the call function or the parse list function. So we get down to around, what is it? Right about here. Read local 123 call. Okay, so that's the parameters of the function. Reading the local variables, which makes sense. Then we're calling it, but the read global is coming from parse operator call, I think. Is that for primitives? Evaluate the first expression if it's not an operator. Yeah, it must be right here. I don't know why I have this left paren check, but it doesn't seem to make a difference. So we parse the expression, but for some reason it doesn't like it. Let's see, printf parse call symbol expression after. Ugh. Let's take that out. We don't need that right now. There was something I could use for this. So parse expression. At this point, we are pretty sure it's a symbol. So if we get down here, we're parsing a symbol. Now we have malloc issues again. Is it consistent? Just one print statement is enough to do it. There's something really obviously wrong in here. All right, let's see. Firefox. I gotta ask the question, what does this message mean? Is it due to a free? Allocating space for a pointer. Oh, you know, I must be doing something really stupid somewhere. Let's check. Let me go into something inside of here. I want to trigger a build and see if there's any interesting warnings that may give me an indication of something I'm doing wrong. So function keyword args free is defined but not used. Interesting. Okay, good to know. There's this one here that's a little bit weird. Object up value. That could be something actually. So initialization of object up value from incompatible pointer type. So I wonder if that's part of the problem, because that does have an effect inside of functions. So object.c line 148. All right, so making closure. We make a closure every time we create a function, so that could be a problem here. Object up value star. Does that even make sense to pass? Guess so. Didn't help though. Also keyword, 73. Yeah, okay, that's fine. I mean, that's expected. Keyword, object, fine, whatever. String. Or is it string dot? Okay, string dot. Just, you know, clean up some of these issues here just to make sure that's not something dumb that I'm doing. Still getting the malloc issue. Okay. Interesting to know, though. Let's go back to the closure function. I wonder if something... Well, no, it would be happening there, wouldn't it? Okay, since it's consistent, let's go to GDB. Run. BT. So there's something going on inside of adding chunk constants. I wonder if I'm holding on to a pointer incorrectly. It's always this thing where I'm asking for a new size. It's 128 and it doesn't like it. Excuse me. Very, very interesting. But consistent. Something strange about it. So, all right, let's think about this for a second. Array right. We're doing a realloc. Let's go back to array right. That's in value.c. Array right. Let's see. Grow capacity. We're taking the old capacity, calculating a new capacity. We're telling it to grow the array. Yeah, grow array mem. Let's make sure I'm not using that wrong. Array values. Where is grow array? Is that in mem.h? Grow array mem realloc mem pointer old size new size. Let's go back into mem.c. Realloc mem pointer old size new size. So that's technically speaking the right way to do it. Just don't understand why realloc doesn't like it. Realloc allocate null pointer. Yeah, so it's deferring to malloc here. Illegal because using a value of an uninitialized non-static local variable p. Static int p. Okay. Okay, let's think about this for a second. Am I passing in the wrong thing somehow? We don't need a pointer to a pointer, do we? I mean, the pointer itself is null, so it doesn't matter. So it should just be giving us new memory. I don't understand why malloc is getting upset about that. Right, it's out of bounds for the allocated memory. Well, we haven't even gotten there yet. That doesn't make any sense. me make sure that I'm passing the right thing. I'm passing new size. If it's 0, I'm going to try to free the pointer. This doesn't make sense. Let's see. Definitely what you want to see me doing here, just scratching my head, figuring out what's going on with random memory issues. All right. Enough complaining from me. Let's get to it. It's pretty clearly happening right there at the malloc call, isn't it? If you go back to this, which line does it say it's at? It doesn't say which line, does it? mem.c40. Okay. Line 40, which is the realloc call. Mem pointer, which is the correct thing. It's null in this case. Let's see. Let's just do this. Printf if mem pointer equals null, which is a totally fine thing to do. We're going to go kill that one and then go to compilation buffer. This just doesn't make sense. Does not make sense how printing something can cause it to wake up. Something is very, very wrong here. Let's go check the code and see what the code's doing now too. Find global, read global, blah, blah, blah. Where is the stuff that we're trying to call? Font load. Okay, that's fine. We're looking for font load internal. Where's thumbnail? Never see that show up. Width, height. Oh, we're gonna get back up here, I think. Yeah. Okay, so mem pointer is null, shows up quite a lot because it's something that happens often. This is how we're allocating memory and freeing memory with a single function. Yeah, it's just very strange how this is happening. Something that also irks me a little bit when I see memory pointers like this, but I guess that's because it's stack allocated. So this is coming from the stack, because that's how the compiler works. You create a compiler context on the stack. Also a VM. The VM is created on the stack too, at least in this case, where I'm calling it from main. But I'm not passing a pointer to it. Nerd says that kind of error usually means that the metadata of malloc was clobbered. It only errors when you realloc again, because that's when malloc validates its metadata. Thank you. That's actually really helpful. So something else I'm doing, there's some pointer somewhere that I'm writing to that's probably writing over malloc's information. The question I have is, why is it that when I add another string... Okay, so psych debugging time. Constant strings are stored in a string table. I wonder if I'm mishandling a constant string somewhere. Like I'm getting a pointer to a constant string and I'm trying to write to it. I'm writing over that location in memory. But I would think that since it's in a different segment, that would do a segfault right when I try to write to it. So I wonder how I'm doing that. Printf also malloc, so that changes the state of malloc's internals. Thank you. That's also very helpful. Okay, so if printf mallocs, interesting, very interesting that this is having problems. Could it just be something that I'm printing even that causes something that like this to happen? This is very strange. All right, let me think for a second. Maybe, should I just go and try to pull in what Ashraz did? Let's go to the Flux Compose repo. Because maybe that will tell me. If that works, then I should probably just turn that on all the time. So Ashraz added the address sanitizer configuration. Let me see if I can get that hooked up here. So f sanitize address, lib use asan. Okay, so that is pretty simple. Maybe I should merge that and then rebase. Let's just do it because I need something to tell me what I'm doing wrong here. Okay, so now I'm going to go stash everything here. I'm going to pull. Should just be able to pull straight from master. There's no rebasing needed. Then pop it. All right, and then kill that. Go back to compilation buffer, run it again. We'll see what happens here. Okay, so something is getting printed out. Let's see what happens. Whoa. Mesh object make string heap buffer overflow. That sounds like it, doesn't it? Okay, so we're definitely using this from now on. That's amazing. Okay, mesh object make string. So what am I doing that's wrong here? Let's see. Shadow bytes around the buggy address. I wonder if the alloc I'm doing is wrong. Object string, object kind string. Hold on a second. The EX size of type plus extra size. And then the object kind. So object allocate. Oh, well, that's obviously wrong, isn't it? No, size up. Okay, size up should allow me to get the size T and then add extra size to it. And then type here. So I'm guessing these are the bytes that are able to catch something going wrong, and then we can see that there's some overwrite into that area of the buffer. So then maybe what I'm doing then is it's like a mem copy or something that I'm doing. Make string. Mem copy. String cares. Where's cares? Length. And then length plus 1. Is that possibly what it is? Well, let's try this real quick. I mean, can't hurt, can it? Whoa, something else? Oh, okay. So that seems to have helped that one. So maybe this calculation is not good. And maybe where I'm calling it, so let's check for make string calls. vm.c string length name. Well, no, it could be there actually. VM name, string length name. Okay. Huh. Okay, let's take a look a little bit more closely here. Mem copy, string cares length. Let's over allocate a little bit. Same thing probably in make keyword. So if I put a +2 there. Incredible. Okay. And then we get a lot of details at the end, which is probably going to help me figure out what's going on. So I got to give a big thank you to Ashraz for setting that up, because I think that solved the problem. Let me... Wow, indirect leak. Leak. See, the drivers are leaking a lot of stuff here. I don't want to see all that, though. That's just too much information. Okay, so we're leaking from... leaking 16 bytes? I really got to take a look at this because... man, there's just a lot of information there. Detected memory leaks. Yeah, I'm probably not freeing all the textures. That makes sense. Okay, there's a lot of stuff that's not being freed at the end of the application, but... all right, so now that I figured that out... what is all this extra? Oh, probably because I have... is it garbage? What I probably should have been doing here, right, is... just saying length. Isn't that right? I don't know why I have +1 there. Seems kind of stupid. What else uses this? Length +1. Make symbol. Let's fix this one also. And then free size length +1, length +1. Okay, so that would explain a couple other things too. So I'm going to go look really quick if we did, in fact, load the font. Where is font? Yeah, still, that symbol for font load internal is not showing up, and I have no idea why. So let's go back, take out some of this crap I'm printing out. Let's just get rid of this stuff. Parsing. Parse. Okay. Get rid of some output. Make it easier to take a look at what I'm doing. Okay. So this read global is wrong. Something busted is going on there. And I don't know why. Because it's a perfectly valid function call. Font load internal. It's curious. And it does seem to pull the local variables next. So something, it just doesn't like reading this one for some reason. If I take that out, what's it do? Constant instruction. Okay, it points to the 0 page. Interesting. Okay, so I think something is uninitialized. Let's go to compiler. There's got to be something really clear that's going wrong here. So whenever it looks for read global, it's doing this parse identifier thing. So parse symbol, variable constant. Abadan says no chroma key issues today. Yeah, I do have issues. I'm trying to mess with this stupid thing the whole time. All right, so let's see. Let me figure out. Okay, printf. We're gonna print out the variable constant. Emitting global read for constant D. Who knows, man? Variable constant. If this is actually going to do something useful. All right, emitting global read for constant 0. Now, it's 0, right? The disassembler emit bytes, reading the global, variable constant, parse symbol. I wonder. Do we have an issue with reading globals? That must be what it is, actually. Trying to read a global in the context of a function body. Because there's a scope now. Local index is not 1. What does parse symbol do in this case? Parse symbol. Tries to resolve a local, okay. Huh? No, that's not right. Can I go to definition? All right. Declare variable. If scope depth is greater than 0, return. That's not right. Yeah, okay, so this is the problem. We're not actually emitting anything. What am I doing wrong? This is a pretty major issue, actually. So, I'm pretty sure the book told me to do this, but I have sort of switched around the code to the extent that it's likely I missed a step and did something wrong here. So I'm calling compiler parse symbol, but we shouldn't be really dealing with that right here, because we need to know first whether it's a global variable reference or not. So parse symbol, read global. So we already know that it's supposed to be a global read because we tried to resolve a local and it wasn't there. However, we go into compiler parse symbol, and all of a sudden we say, oh, the scope depth is greater than 0. Let's just bail out of here. That's wrong. That shouldn't be happening. So parse symbol, is there ever a case where I want it to do that for me? And when I'm calling parse symbol, am I always in a case where I could pass in information about whether it's going to be local or not? Yeah. Okay, so here's what we can do as a way to skip this problem for now. Probably needs a better solution though. Is global. I think this is going to be a real problem. Hold on. Let me check out eval expression. Parse expression, that's the one. So I don't have that info whenever I... Oh, parse identifier. Okay, parse identifier. Where's that at? That's this one. Great. So then I should know in every case whether it's global or not. So how about if I go back to parse symbol, is global. This is an internal function, so I don't have to worry too much about that. Now, if not is global, I don't know. This is kind of a terrible way to do this, because if it is global, we want to go and automatically write out something for that. But if it's not global, then we do it based on the scope depth. Parse symbol. So every time we call it parse symbol, this is in a set. If there isn't a... Okay, so then here we know it's going to be a global. Parse symbol, this is going to be a local. So I'm going to say false here because this is inside of a let. Here, parse symbol in keyword list. Yeah, this is going to be a local. Parse symbol, variable constant. This is where define. All right, we don't know yet. But let's just assume that if you're using define, it's global. Okay, so that's enough. Now, let's go check. Ah, okay, so it worked. But it also crashed. Flux font load file did something freaky, which doesn't surprise me at all. Font C, line 99. Ooh. Really? Current care is Flux font cares. I set something? I wonder if it's one of these is kind of busted. All right, let's see. Right size 4. That's interesting information to have. 99. So it could be this width if it's an integer. So you went 32. Okay, so 4 bytes makes sense. Keep buffer overflow. So somehow we're writing this wrong. Current care texture dot width. And this Flux font cares care ID minus ASCII character start. I must be doing a calculation incorrectly. So ASCII character start minus character in plus 1. Let's take that plus 1 out. How about that? Okay, so that seems to have helped. Freeing native pointer. Oh. Ah. I think it GC'd. Did it? No, I can't have. Oh, okay, so. Freeing native pointer. I wonder. That's interesting. Shouldn't have gotten there yet. But at least we did figure some things out, which is good. It sucks to have to get to that point, but I mean, you know, to have to deal with all this memory issues until we got there. I'm kind of surprised I wasn't seeing all this before, but all right. So emitting global read. There we go. Okay, so now we should have a bit more consistent execution. Hopefully it won't be crashing on every single thing we do. Great, loading font spec, and that loading font spec is actually coming from inside the function. So we are successfully invoking that native function now. Excuse me. And it does load the font. It finds it. Flux icon. Excuse me. Resolve the font path. Loaded the font information. So we did have that. That's great. Let's see. I wonder why it's saying freeing native pointer. It shouldn't be freeing it that fast. Excuse me. So let's roll back to just taking a look at the high level again, just to make sure that we have everything we need here. I mean, we could do image loading here also just to get the image load internal. Excuse me. I'm getting over a cold, so I'm having a little bit of issues with my voice. So I could load those two images if I wanted to. And in fact, let's go into graphics.c. Let's stop all of the, excuse me, the loading from the previous render, or see Flux graphics render test. Let's just stop calling that. Because I don't want to load all that stuff. Okay, so now we've got a lot less noise to deal with. And I can go add the function for loading the images. I'm going to just copy and paste this to get started quickly. I'm going to go into texture.c, flux texture, func, image, load internal. And then we need just one argument. Excuse me. Probably shouldn't have to do that validation of the arity. Flux texture equals null. And then the path, file path. And then we don't need that anymore. Don't need this. We can really just start returning the result. So I'm going to make a flux texture equals, was it flux texture PNG load? Flux texture, I need to obviously look at the extension before I do this. Texture PNG load file underscore path. And then here I can say texture. I'm just going to return the pointer to the texture. Yep, and do that. Then I can take this, bring it over to flux.h under texture. Drop that there. Grab the name of this function. Go to main.c and then drop it here as well. Whoops, let's just grab that. I'll paste this in. Then jump back to this right here. Image load internal. Now it should be able to be executed when I do this. So we initialize the graphics thread. Image load internal. Image load internal. Why did that not work? Yeah, memory links I don't care about. Image load internal. Let me make sure that in thumbnail I'm saying the right thing. Image load internal. Internal. Yeah, that would make a difference. Okay. So I believe we did. Let's see. The texture is okay. So we are loading. Great. So we're actually calling through. Our native pointers are being freed, it seems. Let me think about that for a second. Yes, I think that in my GC code, mark, gotta check which types I'm looking for. So add the object to the gray stack if it has references to trace. Yeah, we don't need that here, but we still need to be able to mark it. So I wonder if I'm also using a switch somewhere right here, darken object. Closure function up value. And that's, let's see, trace references, sweep objects. I'm trying to remember exactly where. Mark roots. Mark roots. It's being stored in the globals. But maybe since it's not in the stack. Is that why? Oh, okay, we're marking the globals table, so it should be in the globals table at least. But if I need to catch it at the right time. Defining a scene, scene is T. It's kind of interesting I'm getting this readout right here. Ah, okay, it makes sense why I did that. Okay, so freeing native pointer. Yeah, it's okay. Let's turn on the GC logging really quick. I'm kind of curious to see what's happening. So mem.h. All right, so we're doing allocations here. And GC decided to occur at some point. Freeing a bunch of stuff. Why? Because the script finished? Yeah, maybe because the script finished it. All right, that's fine in that case. But that does beg the question, how are these things going to stay in memory? The VM needs to stay alive. What am I doing in main.c? Something's going on there. Ah, okay. So this is the point. We need to wait for this to complete. Boom, right here. We're waiting for the graphics loop to complete, and then we're going to free the VM. Okay, that explains everything. Cool. So now I think we won't be seeing the freeze happen until I close the window, and then it will start freeing things. Cool. So let's go back to mem.h. We're going to turn off the logging of GC because we don't need all the information anymore. And then everything loads up. Okay, we've got everything there. So we are at the end of the time for the stream. Let me just double check where we're at, because we did some stuff that's useful here. We were able to load a font and load the images, and it's stored in the global variables of the VM of the language. Now we're at the part where we need to be able to say what the members of the scene are and create the scene object itself. This will require setting up a list object type, and then when we have that, then we're going to be able to say, all right, I want to have an image on the screen at this location, and we'll be able to use one of these image variables we have to say which image we want to draw. And then also the font, we can say I want to draw this certain string of text and get it on the screen. So since we've actually made progress to the point where that can be done, I think next week we can finish this up on Tuesday, and then go from there to excuse me, to work on other things. But I'm very thankful to Ashraz for having adding the address sanitizer code, because it did help us figure out what was going on, which was very strange, and it just pinpointed exactly what was happening. So that's extremely useful. So I'm gonna go ahead and check in. Well, I should probably check in some of this code. It's kind of half baked, but maybe it can be checked in. I'll check it in as we have it right now, and you can check it out if you want to. Check out the show notes after the show if you want to see a link to the commit whenever I get that up. I'm going to do it right now, basically. And hopefully it wasn't too boring today. I know that debugging memory issues isn't everybody's idea of fun, but I think now it should be easier going forward because we have the right tools to do that. So anyway, we'll see you again on Tuesday. Hope you all have a great weekend. And until next time, keep it creative. We'll see you.